Okay, welcome back to another episode of AHC Garage, and we are going to be doing an engine breakdown, teardown, and diving into what's inside this motor and just some of the key features of it. Now, me being a mechanic, and hopefully some of you guys are interested in the mechanical side of things, I love to take things apart and see how they work. That's probably why I do this for a living. So we're going to take a dive into this J35Z2 engine. It came out of a 2013 RDX. The car came in making a very bad noise and about 3 quarts low on oil. So once we put the oil in it, we got it running. It was making some kind of horrible noise, and the customer opted to put a used secondhand engine into the car. And this is how we came to acquire this engine. So what we're going to do is we're going to break it down from top to bottom, try and find the failure point, show it to you, and along the way, show you some interesting things that we see, some failure points that we see regularly on here, such as oil leaks and just all the other things that require maintenance on this type of engine. Maybe give you guys a little better understanding of what we got going on. And that's pretty much the plan for this. These are always interesting to me. I hope you guys enjoy it. We're going to tear this thing all the way down. Here's the motor. We're going to start breaking it down. We're going to start real basic, getting the manifold, getting the valve covers off, maybe taking some of this coolant stuff off, because the goal is to get the heads off, then get the pistons out, then get the crank out, break this thing all the way down to the bare. So we're going to go ahead and start pulling off this manifold. A couple things I want to point out to you guys. As you can see, some of the maintenance issues that are common on this style engine is the intake manifold and valve cover gaskets. They're made of a type of magnesium that does deteriorate over time. If you take a look right here, you can actually see where it is coming apart. And let me get my little thing here. You can see it's literally breaking apart this piece here. You see it fall right off. It is literally disintegrating. You'll get codes, such as like right in there as well. You can see it all coming apart. You'll get lean codes because this will create a vacuum leak, and that will cause a lean condition on the engine. So this is one of the maintenance points on here. And also with the valve cover, it's made the same material. You see it turns straight to dust. And if you look like right down in here by the spark plug tube seals, even changing a valve cover gasket isn't going to work on this because what it goes into is damages. The gasket itself isn't even leaking. The valve cover is failing because it has a hole in it. So that's some of the first stuff I can tell you as far as maintenance goes on these. We'll pull it apart and show you more. So right underneath here is the first plate. This will show you inside of the plenum. This is our EGR port, and these are the runners, and this is kind of part of the manifold and how it routes the air and EGR gases back into the engine. Let's go ahead and get this off. All right, so now once the upper plenum is off, you're left with your lower plenums. This being port induction, that means the injectors, or port injection, I should say. It is injecting right here into the intake manifold. Now, the newer motors are direct injection. Those inject directly into the cylinder. It's a little bit more efficient system, and it allows the combustion to be completed with more efficiency. All right, so let's keep pulling stuff off of here and see how it goes. So you can see here, there's a lot of carbon in here. This is where you're going to want to do fuel induction services and stuff like that. It helps clean all of the oil and stuff that gets recirculated into the engine through the PCV system, which is through this valve cover port right here. And there's another one that comes off of this head right into the intake, and what that does is it takes the crankcase pressure and gases and recirculates it back into the motor, causing some residue. So that's another maintenance point. Just pull the valve covers off and see inside. So here are your spark plug tube seals. These get really brittle. You can see they're not soft, they're hard. When we do valve cover gasket jobs, we replace these. And the seal here, you can see the seal is definitely very stiff. It was leaking a little bit, not a ton, right here. And then inside here, you can start to see some of how this engine works. It has a single cam deep down inside the head. And this one here, you can see these rockers are different from these. This is called VCM, Variable Cylinder Management. It can disengage the cam from the engine. And I can already see some significant wear on what must be coming from the cam on that rocker right there. So we're starting to see where some of that noise may have come from. So you can see right here, everything's a little darker on this end. This side's not as much. That also corresponds with the PCV valve or the vent hose that goes to the intake manifold. It's just congregates the oil and some of that vapors on this side. That's why you see it's a little dirtier here. The side's much cleaner, but same thing here. You see it's a little darker. This is also the side of our vent. So if you can see the rocker down in here, it's all smooth and not pitted, but on the other side over here, you can see it's pitted, which probably corresponds to some damage on the cam as well. So we're going to go ahead and keep pulling apart and see where the problem lies. Now we're going to pull off the coolant neck. This is where the coolant goes in and out of the engine and connects the cylinder heads to the water pump, which is inside here. It's also where the EGR valve sits. You can see right here, these are the cam end plugs. The cam comes out this way, and there's a seal on here as well that likes to leak. It's just an O-ring. We'll show you that in just a minute. Don't recommend using this method to remove this on an engine that is not being scrapped. You want to take your time and pull it apart. This engine's not going back together, so we don't care if we damage the mating surfaces. But you want to be very careful when you pull this off because there's no rubber gasket, it's a metal gasket. So if you gouge any one of these mating surfaces, you will get a coolant leak. But since we're not going to be reusing this engine, I'm not too concerned about it. Also, what's inside here is your thermostat housing. The thermostat's right inside here. We'll take this cover off so you can see it. This here is your thermostat. What the thermostat does is a valve that restricts the flow of coolant in and out of the motor. So you would ask yourself, why do you need that? Now, if your coolant flows too quickly through your radiator, it'll never get a chance to cool properly. You have to have the coolant in the radiator for a certain amount of time so the air can come across it and cool it. And that's what this does. This spring in the back heats up with the coolant, and as it heats up, it loses its pressure and this valve opens up. If you were to put this in water about 200 degrees or whatever the temperature rating is on here, I believe it says 82 degrees centigrade. So once it gets to there, this spring will soften, the metal will soften, and the valve will open up, allowing coolant to pass through. This is what warming your car up. This is the part that you're waiting for your car to warm up. And then that in return warms your oil and all of the metal up in the motor. This is a good maintenance part. So you see right here, this is part of the EGR port. We have another port here. You see this one was all completely clogged up. That would give you a definite code for EGR system malfunction. Now we're going to pull off the cam plug caps and show you that seal that likes to fail on that. So you can see right here, this is a O-ring that sits right inside there. This O-ring gets hard after years of oil sitting on it, and you can see here, try and get it out. You see it broke real easy. This is the little O-ring. This is the prime example of a $5 part with a labor expensive repair, because you have to remove all these things to gain access to it. A lot of the repairs on this motor, the part is not the expensive part of the repair, it's the labor to get to it and change it. Again, same exact seal on the back head. So this pipe here is the pipe that connects the water pump to the coolant housing. It's held in with O-rings. Once these have been removed, you want to replace these, and when installing them, you want to make sure you put some lubrication on there so you don't run into any pinching or leaking. Right here is the drain for the block. This drains the coolant from the jacket that's around the cylinders, which we'll show you when the head comes off. But you definitely, when you're removing the cylinder heads for, say, a head job, you want to drain here, and there's another one right over here. Right there. I'm going to turn it all the way, Mike, because the oil's going to come out. All right, so we're going to go ahead, since we got the motor upside down, we're going to pull the oil pan off and see what's going on. So also you can see there's a lot of oil here. We tend to get oil leaks from our oil pump area in a couple different places. One place is from where the oil filter housing attaches to the oil pump. There's a gasket in between there. All gaskets are going to get hard and wear over time and start to lose their thickness and create an oil leak. That's what's happening in this area. There's another place we'll show you once we get the oil pump off. Now let's get the pan down. Here's the inside of the oil pan. You can see that we have a sludgy buildup in here. This can be from two different things: from it sitting without a lot of oil in it, so the thick stuff collects, or from improper oil changes. Also, we have one sensor in the oil pan. This is the CKP, or the crank position sensor. This is a magnetic pickup that detects this right here. This is the actual trigger wheel. Every time one of these little tabs goes past it, it picks it up as a signal here, and it allows the engine and computer to know the exact position of the crank. And also there's a cam position sensor, and with those two things, it can figure out the proper timing and ignition sequence for most efficient fuel combustion. All right, so underneath here, we have the oil pickup. This sits submerged in the oil pan in oil, and it sucks oil directly from here into the oil pump. So if this is clogged, then you will lose oil pressure to the motor. There's also an O-ring that goes between here and there. Without that O-ring, you will get cavitation and air pockets and lose oil pressure and explode your motor. There's the O-ring right there. This here is called the windage tray. What this does is it tries to create a barrier for all the disturbed air that's created by the bottom end rotating around. so that it doesn't cause bubbling or disruption inside of the oil. And here you can see the crankshaft, our main caps, and our connecting rods, and this is our oil pump. All right, crank pulley bolt was already loose. That was the keyway. It fell. That's an important part. You don't want to lose it. On this car, we're not carrying. Well, it's not a car, it's just a motor. Also, if you saw, our oil pan was made of aluminum, and that means we can reuse it. Also, when you see this kind of, this car didn't have an oil pan gasket. So if anyone tells you your oil pan gasket's leaking on this, they're probably selling you, never mind. You don't need an oil pan gasket. This is sealed with Honda Bond. And it being aluminum, it's reusable, unlike the valve covers and intake manifold. Let's pull off the oil filter housing, and then we'll pull our covers off the front here. You see the gasket? This gasket is hard and very brittle. You can see it breaks. It should be pliable and flexible, but that's what happens to gaskets over time. And this is also, like I said, one of the failure points and leaking parts right here. And this also has a lot of oil pressure in it because it comes straight from the oil pump into here. So if you have a gasket failure here, it'll be a significant oil leak. We're going to flip the motor over and start taking more apart. Underneath here, you can start to see our timing belt. This is what needs to be changed. And once again, these parts are a little bit more expensive because you have your water pump behind here. We'll get to that eventually. But again, this is a labor-intensive repair. And if it's done wrong, it can damage the entire engine and cost you a lot more money. Just make sure whoever you have doing this does it properly. And there's a few things that we recommend you change when you do this. When we take it apart, I'll show you. Okay, so you can see we just removed the side bracket. This is what the motor mount attaches to, right here. And underneath here you can see the water pump. Now I can tell you right now that this is an aftermarket water pump and timing belt tensioner. This looks like it's from Gates. These may be good, but we don't use any of these here at the dealership. We only use OEM equipment, mostly because we can offer a warranty on our parts with that. We can't offer warranty on aftermarket parts. Sometimes a part being cheaper isn't necessarily good because there's nothing backing it up. If one of these components fails in here, you need a whole new engine. So if you save $150 on a part, but it ends up costing you a whole engine, was it really worth the discount? So we always recommend that we change the tensioner, the water pump. If this is showing rust damage, this idler pulley, and this one as well, you can see if they have red dust on it, that would be a sign that it needs to be changed. All right, so if you were taking this apart to do a timing belt, you would rotate the motor to TDC. Since we're not worrying about putting this thing back together, I'm not going to rotate the TDC, but as you can see here, it's been previously marked where this is the TDC, which would be top dead center number 1. That lines up with this mark. This mark lines up here, and then there's a mark right here on the crank that lines up right there. There's no real advantage or disadvantage to us putting it on TDC at the moment, so we're just going to rip it apart. We'll take our gear off right here. There's our belt. Now you can see a little bit more. This is the oil pump area, and you can literally see the oil leak coming down from right behind here. That's where the other seal is. We're going to get to that in just a minute. Here's our water pump. There's no need to put Honda Bond on this. It has a seal. Whoever did that, it's just a little overkill. What tends to fail on these is the bearing or the seal inside here. Then you'll get water leaking out through here, which this is called the weep hole. Alright, here comes the oil pump. And you can see this is the oil pump gear. This is technically what creates all the oil pressure. It rides right in here. It's key to the crank. And this is that other seal I was telling you about. And when someone says their oil pump's leaking, this is what's leaking. This seal here, I barely ever see the actual crank seal leak. It's always made of very good material. Never really have issues with that. But we always change that and this and the gaskets on the oil filter housing we showed you before. Yeah. There we go. We got the cam gear off. And you can see right here, this is the cam position sensor. And these are the pickups where it detects the position of the sensor. We're going to pull that off as well. Oh, that was easy. Underneath here, you can see the cam seal. We're going to remove this crossover pipe because now we're going to work on pulling the cylinder heads off, and this is one of the things that holds the two heads together. Alright, so we got the bases of everything broke down. We're going to go ahead and remove the rocker assembly and the cam from the head before we pull it off, just so that you guys can see it. The cool thing about this head setup is you don't actually have to pull that apart to remove the head, but we're going to do it anyways. I want to see what the damage is like on the cam from this bad roller right here. Right here, this is VTEC solenoid here. This is our VCM here. That's for the variable cylinder management with the cylinder shut off. Like I said before, it can disable the rocker so it can run on fewer cylinders when you're cruising, but when you need the power and the demand, it can re-engage the cam hydraulically and then give you all of your horsepower back. So we're going to pull everything off as a unit. Alright, so you can see the different lobes on here. These will be, intake and exhaust lobes, as you can see. You see how they're all pretty smooth and consistent till we get down to this one here. And you can see that either the roller failed or the cam failed due to an oiling issue that caused this on here. And this is something you'll see not too common in a Honda. I've only seen this one other time. This is probably due to the low oil. This car came in about 3.5 quarts low on oil. It only takes, I think, about 5. So you could see where that damage could be caused. So I'll show you how we pull the cam out. It's pretty simple. Comes right out the back here. You can see it's filled with oil. Alright, so we'll go ahead and flip this over. And you can see here the pitted and failed roller and where it interacted with the cam right here and wore it out. This is probably the noise we were hearing. We've seen it where this bearing will fail too, but it didn't do that on this one. And we're going to do the same thing on this one. All right, so it's time for the head to come off. I want to stress this is not the right way to take the head off. You should break this loose with a breaker bar. Like I said, this engine is not going back together at all, so we should be able to do it with this alone. No, we're not. Let's give this a shot with the air gun. Yeah, there we go.
Sean, what happened?
It needed my brute strength in order to remove it. This would be the proper way to remove it. You always want to start on the outside and work your way in. That prevents warpage of the deck. So here we have the cylinder head, and you can see this thing has got extensive carbon buildup on it. Probably a low quality gas, not very good maintenance. It'll cause stuff like that. So if you see here, just like on the cylinder head, look at the carbon buildup. That's crazy. That's what low quality gas gets you. Right there. All right, we can see here, same thing like we said, mostly carbon buildup. Everything looks like it's in decent shape here, but you can always tell if a cylinder is running different than others because the colors don't match and maybe there's more carbon on one cylinder than the other. That can be injectors, that can be spark plugs, it can be a number of different things. Situation, tons of carbon on everything. We're removing here is the rear main seal or crank seal housing. This is something that we also get pretty regular leaks from at high mileage. Once again, this is the actual seal that rides on the crank. This one doesn't usually leak at all, but this O-ring right here, which is the end of the oil gallery that goes from the front of the motor all the way to the back to supply the entire engine with oil. This $4 O-ring right here costs a significant amount of money because you have to remove the subframe, the transmission, in order to access it. And that right there will cause a heck of a mess on your driveway, so that you understand what kind of work is involved in fixing some of these oil leaks. All right, so we're almost down to the end here. So now, in order to finish disassembling the bottom end, we have to remove the pistons from the block. That first means we have to disconnect the connecting rods from the crankshaft. So we're going to go ahead and do that. It has these two 12.10s. Inside here you can see the rod bearings. These are removable and replaceable, and they come in different thicknesses. The thicknesses allow for the size differential between the connecting rod bore and the crankshaft diameter. And there's a spec that's supposed to be within. So you'll have different color ones. Those equate to different clearances. And with the right combination, you can get the perfect clearance, I should say, inside here. So let's go ahead and pull it out some more. Boom. Good catch, Mike. I'm glad you had gloves on. Yeah. I'm sure it was interesting.
And
Yeah.
yeah, shoes. Anything in your life.
What we're doing now is removing the main caps. The main caps have 2 bolts in the middle and then one bolt on either side holding it laterally. All right, and here you can see the main bearings. They're beautiful shape. All of the coating is still on it. This thing was actually running very, very well. And on this next one, we're going to show you the thrust washer as well. All right, now we'll see it when we get it out the rest of the way. There we go. Almost there. Okay, so we're going to pull this out right now. We're going to show you the thrust washers. They may fall down. The thrust washers pretty much do exactly what it says. It stops the lateral movement of the crank. There's a little play that's allotted into it, a few thousandths, and if you could see right here when I move it, that's the allowable play. But that is set by these 2 washers right here. When I pull the crank out, you'll be able to see them. You see right here, these are the thrust washers. They set a clearance for the crank for lateral movement. If you ever have these left over after you rebuild a motor, you're going to be rebuilding it again real soon. What you see right here are oil squirters. What these do is they cool the back side of the piston by squirting oil onto it from the bottom. Some high performance motors eliminate these as far as race cars will go, but for efficiency, this is it. So if you want to take a look at a few more things on this, we have broken it down pretty much all the way. The only sensor that's left on here is the knock sensor. This detects detonation inside the engine. Detonation is when a spark goes off, not when the engine is telling it to. So they call it pre-ignition. It can be caused by that carbon buildup, leaky injectors, bad timing, a bunch of different things. But detonation is not good. This will detect it and adjust the timing accordingly. Now if you go ahead and take a look inside, you can see the cylinders. Cylinders look to be in beautiful condition. This is the piston and where it rides on it. These are our rings, our oil ring, our scraper rings, and our compression ring here. You can see all that carbon buildup on it. Once that carbon buildup gets too heavy on this ring here, it does not allow the rings to scrape the oil off the sides of the piston, which will cause smoking in the cylinder. So these are the basis of the V6 J35 motor. Every other J series motor is very similar to this setup. There will be differences in the head, possibly in piston design. In a J37, it's going to have a little bigger bore. And also you're going to have the big differences in the heads. Port injection, direct injection, high pressure fuel pumps, different types of cylinder management. But in the end, this is basically our V6 motor. This is the bones all the way from, what is it, like 2000, or I say 98, and our CL and TLs and stuff like that, you know, as they've come up. This is the J series motor. They're all going to be basically the same. So all of these failures I've shown you are going to be pretty similar through all of the years. So if there's stuff that you're not sure of when you go to service your car, you can take a look at this video and kind of get a better idea of what it takes to do the repair, what the failure points are, and what it actually looks like. So when someone tells you you need a new valve cover and not a new valve cover gasket, you can see why you would need it. This is I'd say one of the most numerous motors that's in production between Honda and Acura, and that also includes, I'd say there may be more of these than our 4-cylinders. It's nowadays there's not as many V6s, there's more 4-cylinders, but this is it. This is everything you need to know about the Teardown. I think our problem was in the head at that one cam where you saw the failure on the rocker. Other than that, I mean, you could probably rebuild this motor, put it back together, replace parts of the head, the cam, and then get it back on the road. Nothing on here is completely unsalvageable other than that cam and the rocker. But I think all this is going to scrap, and I got myself a nice bucket of bolts. All right, so now you see it all blown out and broken down. You saw the failure points. You saw some of the maintenance things on it. Maybe you have a little better understanding of the J-Series motor. I hope you guys enjoyed it. I love this. You've seen us tear down B-Series, H-Series. You haven't seen a C-Series. That would be the NSX motor. J-Series and K-Series. So we've gone through most of the engines that Honda has to offer. If you guys have a suggestion for something you like, I think the next one's going to maybe be a KC or an L15. Once we get one of those, we'll definitely break one of those down for you. But let us know what you think about this. Let me know if there's any other stuff that I didn't mention that you guys know about. Interact with us. We're here to talk. I hope you guys enjoyed this. Be sure to like it, ask questions, subscribe, and you can see a lot more stuff like this. And definitely catch us on our next videos, because we're going to have lots more interesting stuff. See you guys on the next one.